Assalamualaikum warahmatullahi wabarakatuh. We would like to say thank you for coming to our presentation. It's great to see you all. In this presentation, we will discuss about Auger Electron Spectroscopy. Okay, let me introduce myself and my partner. I am Anissa Devianti and my partner is Anisha Tri Kurniawati A. We are from Lambda Group. And now our lecture is Associate Professor T.S. Dr. Zaidi bin Embong. A surface layer is defined as being up to 3 atomic layer thick, around 1 nanometer, depending upon the material. Layers up to approximately 10 nanometer are considered ultra-thin films, and layers up to approximately 1 micrometer are defined as thin films. The remainder of the solid is referred to as bulk material. This terminology is not definitive, however, and the distinction between the layer types can vary depending upon the material and its application. The surface will influence such factors as corrosion rates, catalytic activity, adhesive property, wettability, contact potential, and virus mechanism. Surface modification can be used to alter or improve these characteristics. Surface analysis techniques are therefore very important to understand surface chemistry of a material and investigate the efficiency of surface engineering, material values, or the development of new device. Now, what is Auger Electron Spectroscopy? Auger Electron Spectroscopy, or we can call AES, is one of the most commonly employed surface analysis techniques. It is used the energy of emitted electron to identify the element present in a sample. Similar to X-ray photoelectron spectroscopy or XPS, the main difference is that XPS uses an X-ray beam to eject an electron, and AES uses an electron beam to eject an electron. In AES, the sample tip is dependent on the escape energy of the electrons. It is not a function of the excitation such as in XPS. In AES, the collection depth is limited to 1 until 5 nanometer due to the small escape depth of electrons, which permits analysis of the first 2 until 10 atomic layers. In addition, a typical analysis spot size is roughly 10 nanometer. Okay. Auger spectroscopy can be considered as involving 3 basic steps. It's first, atomic ionization by removal of a core electron, and the second, electron emission, the Auger process, and then the last, analysis of the emitted Auger electron. Okay. The history of Auger electron spectroscopy. The Auger phenomenon is not irradiative de-excitation process for excited atoms. The de-excitation occurs by a Coulombic interaction where the atom lost energy by emission of one or more electrons. This ejected electron to one continuum state is named Auger electron. In 1923 or 1925, this effect was discovered independently by Lise Meitner in 1923 and Pierre Auger in 1925.
Third, the principle of Auger electron spectroscopy. When a beam of electron is fired at the surface of the materials, this beam simulates several interactions. One of those interactions is Auger Electron Spectroscopy. The principle of Auger operates by allowing a high-energy electron from the beam to eject an electron from its orbit, creating an empty hole in the orbit. This is the phenomenon of electron collision. This picture shows that electron beam bombard the sample and eject an electron off the inner shell of the atom. This vacancy must be refilled by an electron from higher energy level. As this occurs, another electron from a higher orbit moves to fill the empty space. As the electron changes from a higher to lower orbit, it releases energy. This is the phenomenon of Auger electron emission. Energy from electron emission might eject a third electron from another orbit. The ejected electron is referred to as an Auger electron. By measuring the energy of the emitted electron called the Auger electron, the atom can be identified. That electron has sufficient energy to overcome the binding energy to a function to be ejected with the characteristic kinetic energy. Different atoms have different atomic orbits and therefore different Auger energies. The Auger process requires 3 electrons. Thus, we cannot detect hydrogen and helium, but we can detect all other elements from lithium on up.
Okay, the next, the Auger process. Okay, the Auger process includes 3 steps. 1. Excitation of the atom causing emission of an electron. And 2. An electron drops down to fill the vacancy created in step 1. And the third or final state is the energy released in step 2 causes the emission of Auger electron. Nomenclature for Auger transition. You can see in this picture. First letter is K, is initial core hole location, and the second letter is L1, initial location of relaxing electron, and third letter is L23, is location of second hole or initial location of Auger electron. Conventionally is used the X-ray type in the nomenclature of Auger transition. In this example is K, L1, L23. And then the Auger transition line. For the we can see in the picture is X line, it is kinetic energy, and the Y line is intensity. From the picture we can see the Auger spectra in the differential distribution characteristic of the likeness element.
Fourth, instrumentation of Auger Electron Spectroscopy. The essential components of an Auger Electron Spectroscopy are USB environment, electron gun, electron energy analyzer, electron detector, data recording, processing, and output system. This diagram shows the instrumentation of Auger Electron Spectroscopy. The sample is running through the spectrometer and is usually a solid compound. The sample moves through an electron gun/optical ion source. It is comprised of an ion beam that sputters the sample surface. Second electrons are produced in this step. The data is processed by displaying different peaks of each source. The electron analyzer is usually a cylindrical mirror analyzer. The detector consists of an electron multiplier, which consists the diodes that are connected to a resistor.
And the application of AES: first, qualitative analysis through fingerprints, spectra analysis, and identification of different chemical state of element, and determination of atomic concentration of element, and depth profiling, absorption and chemisorption of gas on metal surface, interface analysis of material deposit in situ on surface.
6. Limitation of Auger Electron Spectroscopy. Limitations are analysis conducting and semiconducting sample. Special procedures are required for non-conducting sample. Only solid specimen can be analyzed. Quantification is not easy. Hydrogen and helium are not detectable as they have electron less than 3.
And the advantage of AES itself is surface sensitive, elemental and chemical composition analysis by comparison with standard sample of known composition, detection of element heavier than Li, very good sensitivity for like element. Depth profiling analysis is quantitative compositional of information as a function of depth below the surface or destroy the sample. And the last, spatial distribution of the element as SEM, elemental or even chemical Auger maps analysis in lines, point, and area. That is all for me and my partner. Thank you so much for your attention. I would like to apologize if there is a mistake. I hope you have a nice day.